Hi guys, in this video I will cover how to calculate the proper QRS terms from the given ECG signal using PanTompkins and then also a little bit of brute force. So this particular code is going to deal with the application of PanTompkins. We have already covered how to create the PanTompkins method in a previous code example. So we will proceed over here from calculating the R curve points using PanTompkins. So if you focus on line 159 over here, you'll see that uh, I have currently commented it because I've already calculated it for this graph, but ECG underscore R is going to store the PanTompkins of our original ECG signal. So PanTompkins function is going to return the integrated ECG signal. That is the last step of the PanTompkins method. And I am going to find the peaks of that. You can see the orange curve over here represents the ECG underscore R. This is going to be put inside the find peaks function, which will calculate the peaks at every point in this data as per the given sampling frequency. And we will be storing those points, the magnitude of the peak as well as the location of that peak in peak orig and location orig. So after applying some sort of processing, which I have not covered over here, but it is fairly straightforward if you look in the Biomedical Signal Analysis book by Rangayan. I'm going to leave a link of how to download it. So the steps of how to calculate the PanTompkins algorithm, as well as the exact code of how to do the thresholding as well as the error correction after calculating the QRS can be seen in this particular function. So all this threshold and the search by calc procedure, it will help you to understand how we can go back from the QRS points to the actual ECG points. If you do not understand this part, you can skip this and also apply the brute force method, which I will cover now. So if this seems a little overkill for your particular application, then you can directly go ahead and find the peaks of your ECG signal. In that case, you just feed your ECG signal to the find peaks method for the same sampling frequency. So it will go ahead and calculate the peaks for every point of this blue curve that you can directly plot as the peaks of this curve and say that those are the R points. So if you have calculated the R points, you can just create some sort of a cross-checking mechanism and say that if the peak is greater than some threshold, for example, in our case, it should be greater than 0.8. I'm looking at it from this line. You can also say 0.9, but that seems like it's a little bit too close. So to be safe, if the points that I'm getting are more than 0.8, only then classify them as the R points. So if you only look at the blue curve between 0.3 and 0.8, you will find that only these points will be calculated as the T curve. So that you can store in your variables. I have stored it in variables T wave cell and location of cell. So this is basically the magnitude and the location, both of which that you need. Next, to find the S points, which are fairly down below over here with Q and S. These points can be calculated if you invert this complete ECG signal and then calculate the peaks. So we can do that very simply. So if you now look at this curve, you'll see that this new orange line represents the inverted ECG signal, and that, let me zoom. So this point now represents the Q and this point represents the S. So we can just simply find the peaks of this ECG inverse signal. That is what we have done over here in this code. And we can set some boundary conditions. For example, to find the S locations, we can say that it should be greater than 0.15 magnitude. So if something is greater than 0.15, this point will be Q position. So simply by using the find peaks and some direct brute forcing methods, we can go on to calculate our QRS points. So once you have calculated that, you can also do the T wave and combine all these points. This looks a little complicated, but so you will find that all your points are properly indicated, and you can look in one particular segment of it in order to be clear. So for example, over here, you can see that your R point has a red dot, and it's not very clear, but this yellow point over here will represent your T wave. And so if we zoom into one of these segments, we can see that the Q, R, and S segments are properly indicated. And the T part over here is also there, but the yellow color wasn't a good choice. Interestingly, we can also form a simple tachogram from the given R peaks by simply connecting the lines between the different R peaks that we get. And we'll obviously get them in the range that's greater than the smallest R peak to the biggest R peak. So as you can see, it goes from zero point 0.9 to 1.15. And this tachogram is very useful in the biomedical field. Thank you for watching.